This is Bigfoot, Varco's Iron Roughneck 2000. It is a hydraulically operated tool which is capable of spinning and torquing drill pipe and collars both in the rotary and in the mouse hole. Maximum makeup torque available is 63,000 foot-pounds, and coming out of the hole, Bigfoot can provide breakout torque as high as 75,000 foot-pounds. The Iron Roughneck 2000 is a safe, efficient, labor-saving tool when used and maintained properly. But, like any other tool on the rig, it must be maintained properly to provide a long service life. For the next few minutes, we will discuss the preventative maintenance procedures and schedules for both the Iron Roughneck 2000 and a Varco hydraulic power supply unit. First, let's look at the preventative maintenance schedule for the Iron Roughneck 2000. There are several items that must be checked before each trip. First, check the jaws of the torque wrench. The dies must be in good condition and the spacers properly placed. Worn or broken dies must be replaced. The jaws should be shimmed for the connection size you will be working on. Check the brass plate to the right of the torque gauge if you are not sure that the jaws are shimmed properly. Now, tighten the Allen head bolts in the face of the piston jaws. Tighten the gate jaws by making up the nut on the outside of each gate. If the jaws are not tight, these bolts can bend or shear and must be replaced. They are available from Varco, but any grade 8 or better bolt may be used. Now lubricate all grease fittings with a good waterproof grease. There are several fittings and you will have to open the back door to get to some of them. In the carriage assembly there are 8 lube points inside the back door for the vertical rollers, 4 on each side. There are 4 lube points for the rollers and the feet, 1 in each roller. There are 18 lube points for the spinning wrench. You should be careful not to forget one. There are 4 lube points for the support rollers, which are located on the vertical mount. There are 2 lube points for the drive rollers. They are located beside the oil pan. The cylinder rod ends must be lubricated through the spinner cage. There are 2 lube points. There are 2 lube points on the bottom of the spinning wrench for the cylinder trunnions. There are also 2 vertical roller lube points located just above the torque wrench. The last 8 lube points for the spinning wrench can be reached by lifting the hinged top cover. Here you will find the 2 lube points for the cylinder trunnions on the top, 2 more lube points for the drive rollers, 2 lube points for the pressure rollers, and the 2 arm pivot lube points. Now let's look at the maintenance on the torque wrench. The torque cylinder rod ends have 2 lube points in the rod clevis. The cylinder trunnions have 4 lube points. These are the lube hoses located just below the control valves. Finally, the gate and latch have 6 lube points, 2 on the gate and 4 on the latch. Now, with all grease fittings thoroughly lubricated, clean and lubricate the control valve rod ends with 10-weight oil. You should also clean and lubricate the torque cylinder rods with 10-weight oil. This will preserve the rod seals and prevent leakage. Now, check the quick disconnect hydraulic fittings on both ends of the pressure and return hoses to the tool. They should be made up tight by using a crescent wrench on the ears. If these connections are not tight, the valves inside them will not open fully, restricting fluid flow and causing the tool to operate slowly while heating up the fluid. The hydraulic power unit should also be checked. It should be checked for the correct fluid level indicated by the sight glass on the reservoir. It should be filled to the top. Add fluid if necessary. The fluid must be clean and of the type specified on the power unit. Now switch the power unit on. Check it and the Iron Roughneck for leaks. Tighten any loose or leaking connections. Remember to use a crescent wrench on the ears of the connectors to get the quick disconnects fully tight. Open the back door and check all hose connections for leaks. Tighten any loose or leaking connections, or if the hoses are damaged, replace them. Now operate all controls to be sure the tool is operating properly. If the tool is not functioning properly, either check the troubleshooting section of your service manual or call your Varco representative. Be sure to check the pressure gauge behind the right-hand control levers of the Bigfoot. This should read 2000 psi. Adjust the pressure at the power unit so that the reading is between 2000 and 2200 psi. Under pressure will not provide adequate clamping pressure to the torque wrench, while overpressure will cause rapidly accelerated wear. When clamping on the first joint of pipe, be sure the torque wrench is level. Excessive movement of the torque wrench indicates the tool is not properly leveled. To level the torque wrench, turn the large leveling screws below the lower torque body. This completes the pre-trip inspection of the Iron Roughneck 2000. You should, however, reset torque on the torque wrench before making a trip. Even if torque requirements have not changed, this should be done. There are several reasons to do this. Vibrations from the rig or the tool itself could have caused the torque setting to drift. Someone, possibly on another tower, could have bumped the torque knob. Whatever the reason, it's always a good idea and an excellent practice to reset torque before making the trip. Let's look at the proper method of setting torque on the Iron Roughneck 2000. First, you should refer to the IADC API recommended torque tables, or your company operating policy, for the torque to be placed on each type connection you will be making. You should remember that torque is measured in foot-pounds, not line pull. Before making up any connection, turn the torque adjusting valve several turns counterclockwise to reduce the torque to a minimum. Bring the tool onto the connection and spin it up. Clamp the torque wrench on the connection. Push the torque lever all the way in and hold it, while turning the torque adjustment knob clockwise. Watch the torque gauge and stop turning the knob when the desired value is reached. In this case, the value is 60,000 foot-pounds for 8-inch drill collars. Of course, this crew will reset torque when they finish running collars and begin running drill pipe. Now, tighten the torque adjustment lock ring and release the lever. The torque wrench will now make up all connections to this value and stop automatically. If while making a connection the torque gauge suddenly drops to 0, this indicates you need to get another bite. Unclamp, rotate the torque body back, clamp again, and continue to torque the connection until you have reached the desired torque value. Now, let's look at the 3-month preventative maintenance schedule. First, you should remove the gear case cover on each of the feet of Bigfoot and inspect the gear train for signs of damage or wear. Pull out on each gear to be sure they are tight. Tighten the motor mounting bolts. Clean the gear train thoroughly and repack it with a waterproof grease. Be sure to install a new gasket when replacing the gear cover. Next, you should drain the oil from the spinning wrench gear case. Check the oil for metal cuttings. Metal cuttings will indicate gear damage. If cuttings are found, remove the spinning wrench from the tub. Remove the oil pan and inspect the gear train. You should replace any worn or damaged parts. Install a new gasket when replacing the gear case cover and then reinstall the wrench into Bigfoot. On this inspection, we found no cuttings, and we are simply going to refill the spinning wrench gear case with 3 quarts of SAE 90 weight oil. Finally, on your 3 months inspection, you should perform all pre-trip inspection and maintenance items. Now your 3-month inspection is complete. Now let's look at preventative maintenance on your hydraulic power supply. First, check the fluid in the reservoir for quantity and contamination. The unit must be kept filled to the full mark on the sight gauge with clean hydraulic fluid. Use only SAE 10 weight hydraulic oil. Be sure that the bucket or container you are using to fill the unit is clean. Never use a dirty bucket. Next, drain accumulated water from the hydraulic fluid reservoir by slowly unscrewing the drain plug. Remember to close it again once the water has drained. Now check the oil filter indicator. If the needle is in the green area, as this one is, the oil filter is okay. If the needle is in the red, you should change the filter. Remember when changing the filter to remove the filter element and inspect it for contamination. Determine the source of contamination and correct the problem. Discard the old element. When replacing the filter element, place the cup and spring over the end of the element and screw on the nut just tight enough to insert the cotter pin. Over-tightening the nut will increase the bypass setting, resulting in poor filter performance. When replacing the filter element, remember to record the date on the decal. The replacement filter part number is on the decal. This element should be changed 2 weeks after first startup, 1 week after every rig move, every 3 months, or when indicated by the return filter gauge. Every 6 months, the pump motor or motors, depending on the type of unit, must be lubricated. Drain and refill the reservoir. Inspect the rubber isolator on the motor to the pump coupler for wear. Record the dates on the decal. Every 12 months, the reservoir breather should be removed and discarded and a new one installed. Before every trip, you should remember to check the hydraulic oil level. Check the quick disconnect couplings and be sure there is 2,000 psi from the unit to the tool. Before we close this program, there are 2 troubleshooting tips that you should remember. 2 things will cause the hydraulic unit to stop. They are 1. Low oil, or 2. Hot oil. Never use the override system for an extended period of time. If the unit stops, there is a reason. Use the override to get off the connection and find the source of the problem before you use the unit again. There are 2 things that will cause the iron roughneck to run slow. The quick disconnect couplings are not tight, or the tool is not receiving 2,000 psi. This concludes the preventative maintenance program on the Iron Roughneck 2000 and Varco hydraulic power supplies. If you have any further questions regarding these tools, call your Varco representative. We'll be glad to help you.
The Varco PS15 spring slip is designed for low maintenance and simple service. However, it does require more careful inspection and maintenance than the hand slips on your rig. These maintenance procedures are divided into 2 categories: those to be performed prior to a trip and those to be performed on a scheduled basis every 3 months or every rig move. A few simple maintenance steps should be taken before each trip. Before placing the PS15 in the master bushing, clean it thoroughly with solvent and steam, if available, to remove mud, dope, and foreign materials from all exposed surfaces. Be especially careful to clean the slip backs and bowls as well as the spring cartridges. When the slip is clean and dry, lubricate the spring cartridges with a grease gun at all Zerk fittings. When all 4 cartridges have been lubricated with a good quality waterproof grease, lubricate the bowls and slip backs with the same grease. Do not use tool joint compound or dope on these surfaces. Dope containing metallic zinc or lead will build up on the surface of the bowls and slip segments and cause sticking of the slips in the bowls. This occurs when the lubricating component of the dope is forced out of the wear areas under pressure, leaving behind only the metal particles. Buildup of this metallic zinc or lead over a period of time can seriously affect the operation of the spring slip. We repeat, lubricate the slip backs and bowls with a good quality waterproof grease only. It is a good idea when installing the PS15 in the master bushing to lubricate the back of the bowls to prevent the slip unit from sticking in the bushing. This may be done by swabbing the bowl backs with grease or heavy oil, or by pouring oil into the crack between the back of the bowls and the master bushing. Before placing the PS15 into the master bushing, inspect the nuts which secure the top cover to the spring cartridges. If the top cover is loose, follow the tightening procedure in the 3-month maintenance check, which we will cover later in the program. It is important to follow this procedure in tightening these nuts. Do not just tighten these nuts. If the top cover is loose, the slips may not set evenly. Broken studs or loose nuts on the spring cartridge will allow excessive motion in the unit. A hand slip in this condition would not be run in the hole, and neither should the PS15. If in handling the unit or during a trip the top cover receives a heavy blow, immediately check the spring cartridges and studs for damage or misalignment. If either condition is found, do not put the unit back in service until it has been repaired by a Varco service center. When you have finished these steps, you are ready for your trip. Pull the drilling bowls out of the master bushing and install the PS15 in their place. When lifting or handling the PS15, be sure to use only the lifting eyes provided in the top cover to prevent damage to the slip. When the PS15 has been set into the master bushing, engage the locks on either side of the bushing to prevent the slip unit from being lifted free should the slip stick in the bowls. The Varco MSPC master bushing incorporates a built-in lock to free the slips from the bowls should they become stuck. As the slips ride up with the pipe carrying the bowls will travel only 1/4 of an inch before striking the lock mechanism. This blow is usually sufficient to free the slips from the bowls and allow the slips to release the pipe in the normal manner. Locking the bowls in the bushing should be considered a primary safety precaution for either the PS15 or the drilling bowls, since the locking mechanism prevents the bowls from being pulled out of the bushing by the slips or dragging tool joints. When the bowls or slip unit is removed in this manner, a possibility of an injury to a crewman's foot is present. Keeping the backs of the bowls clean and lubricated and keeping the locking mechanism operating freely will allow this safety lock to perform its intended function. The pre-trip check of the PS15 consists of 3 steps, as we have seen. Clean and lubricate the slip bodies, bowls, and spring cartridges. Clean and lubricate the backs of the bowls before installing the unit into the master bushing and locking it in place. And finally, check to see that the top nuts are tight. These 3 maintenance steps before each trip will keep your PS15 in top working condition. A few extra inspection and maintenance checks every 3 months will ensure its long and reliable service. First is a thorough cleaning with solvent to remove grease and mud to make the remaining inspection and service procedures easier. When this has been completed, remove the cotter pins retaining the slip hanger pins in the top cover. Remove the hanger pins while holding each slip body up. Lower the body when free into the bowl of the slip unit and remove it through the side opening. When all slip bodies have been removed, clean the bowls thoroughly and clean the slip backs, web areas, and inserts to remove grease, mud, and foreign materials. Remove the top cover by removing the cotter pins and removing the top nuts from the stud on top of each spring cartridge. Lift the top cover clear and set it aside. Turn the unit on its side and inspect the 4 bottom bolts to be sure they are lock-wired properly. If they are not lock-wired, either lock-wire them yourself or call your Varco service center and have them lock-wire these bolts. Inspect the cartridges one at a time. Check to be sure that they are not bent with a straight edge. Next, use a square to see that the stud is not bent. If a cartridge is found to be bent or otherwise damaged, it must be replaced or repaired before the unit is reassembled. Replacement of the spring cartridge is a procedure best performed by a trained Varco serviceman. Now pull the hinge pin between the bowls and inspect it for severe bending or wear. If no apparent wear or damage has occurred, reinstall it using a new cotter pin in the lower end to hold it in place. If it has been damaged, replace it. Install the top cover on the cartridge studs and make up the top nuts loosely. Inspect the slip backs for galling and gouges and the webs for cracks to be sure that each body is straight, the backs show no deep gouges, and that the webs are not cracked. Grease the slips and bowls and install the slip bodies in the unit using a new cotter pin to secure the slip hanger pins. Finally, grease the spring cartridges as you do in your pre-trip check with a good waterproof grease. Now place the unit in a master bushing. Set the slips with the pipe or have 2 men stand on them to fully compress the spring cartridges. This means the foot latch should be well above the top cover when the cartridges are completely compressed. Without releasing the slip, torque up the top nuts to 250 foot-pounds, making sure that the sleeve of the cartridge doesn't turn while making them up. Next, you should cycle the unit several times to ensure that it is functioning properly. If it is not functioning properly, repeat the complete tightening procedure. If it still will not function properly, then something is out of alignment and the tool should be sent to a Varco service center. Do not use a slip which has been damaged or does not function properly. If the unit cycles properly, install the cotter pins in the top nuts and bend them out to secure the nuts in place and prevent them from loosening up. You should check for wear in the wear bushing or guide ring in the bottom of the bowls. More than 3/16 of an inch of wear means the guide ring is worn and requires replacement. Lubricate the backs of the bowls and the slip is ready for service. Regular inspection and maintenance is the key to the service of the PS15 spring slip. These few maintenance tips will keep the tool in top condition and ready for service for many months to come. They are outlined on a laminated plastic sheet available from Varco. You should keep it in your doghouse for ready reference when you service your PS15. The Varco 66 and 6800 Kelly spinners have proven themselves to be low maintenance, low repair power tools. Production models of these tools have given every indication that they will work hard for years with only minimum maintenance. However, a drilling rig does not offer an ideal working environment for any power tool, and there is a possibility that a 66 or 6800 Kelly spinner will eventually find its way to a Varco service center or contractor's shop for repair. In the next few minutes, we will see the teardown and reassembly of a 6600 Kelly spinner. This process is identical for the 6800, as only the motors are different. The 6600 has an air motor, while the 6800 has a hydraulic motor. We have purposely chosen a new unit so that you may see what the unit should look like when it is in perfect working order. Before you begin working on the unit, clean it thoroughly. Once cleaned, drain the oil from the unit. Both models of Kelly spinners use an oil bath lubricating system with approximately 1 1/4 gallons of 40-weight oil. Check the oil for metal cuttings when draining it. Cuttings could indicate gear damage. With the oil drained, you are ready to begin disassembly of the unit. Begin by removing the guards. This unit has an old-style lower guard. When we reassemble the unit, we will put on a different clutch guard. Be careful when removing the lower guard. It's heavy. Next, you want to remove the air or hydraulic hoses to the motor. It may be necessary to hold back up on the bulkhead fittings to keep them from turning when you remove the hoses. Now remove the bolts holding the motor mounting plate to the body. The motor mounting should lift up and off the unit. If the motor is stuck, there's an easy way to remove it. 2 of the 8 bolts on the motor mounting plate are shorter than the other 6. They are not threaded into the body. Use 2 of the longer bolts in their place, screw them in, and they will act as a jack to pry the motor from the body. Be careful not to lose the drive key. Next, remove the gasket. If a gasket-forming material such as Permatex has been used, it may require scraping to completely remove the old gasket. Now remove the clutch hoses. Next, you'll want to remove the bulkhead fittings. Now loosen the 2 screws holding the seal retainer cover in place. The seal retainer cover may then be pried loose with a screwdriver and removed. The 8 bolts and lock washers holding the seal retainer in place may be removed and the seal retainer removed. Now remove the bolts from the chain torque arrestor fittings and the remaining bolts holding the bodies together. You will need to hold back up on these bolts when removing them. There is also 1 bolt on the bottom of the unit on the clutch plate. Remove the split ring and the bearing retainer spacers. Next, you'll want to back out the bolts holding the clutch housing in place, but do not completely remove them. Using a brass rod, drive the clutch assembly down until it is free and resting on the bolts. Hold the clutch housing in position while you remove the bolts, and then remove the clutch housing. You should remember that it is very heavy, so don't drop it. Install the eye bolts, as you see here, to lift the bodies to separate them. Remove the shims, and you're ready to separate the body halves. Before you can actually separate the 2 body halves, you will probably have to heat the roller bearings, as you see here. With the bearings hot, the bodies should separate easily. Remove the bull gear and the drive key. The lower body may now be removed by removing the lower seal retainer cover and the lower seal retainer.
Now, with the unit completely torn down, inspect all the gears in the unit. This includes the gears on the clutch and the large bull gear. Look for any signs of damage and replace any broken gears or damaged parts. Inspect the O-ring inside the seal retainer. If it is worn, damaged, or cut, replace it. Remove the snap ring holding the bearing in the top cover. Turn the top cover over and press or drive out the old bearing. If it shows signs of damage, replace it. You should also pull all the gears and bearings from the clutch assembly and inspect them for damage. Finally, check the roller bearings on the shaft to be sure they are in good condition. Again, if you find any damaged parts, replace them. It should be pointed out that if you find worn or damaged parts, you should also try to determine the source of the problem. This will serve two purposes. It will help our customers maintain their tools better, and it will help Varco eliminate potential problems with our tools. Now, with all parts thoroughly inspected and any damaged parts replaced, you're ready to reassemble the unit. Reinstall the lower body and the lower seal retainer. Be sure when you install the lower seal retainer that this plug must be opposite the clutch. The plug is used to drain oil from the remainder of the assembly during disassembly. Now put the bull gear drive key in its slot. A little coating of grease will help keep it in place, and put the bull gear in its place. As a routine part of the job, you should replace all the removed gaskets with new gaskets during reassembly. Now you're ready to reinstall the clutch housing on the lower body. Use a new gasket when reinstalling the clutch housing. You can hold the clutch housing in place and put in the bolts, but if you're working alone, here's a trick that could help you. Place the clutch housing on the edge of your workbench. Lift the Kelly spinner off the stand with an overhead crane. Move the spinner over the bench and carefully and slowly lower the unit onto the clutch housing. Once this is done, replace the spinner back onto its stand and bolt the clutch housing in position. Now blow or wipe out the lower body half to be sure that there is no debris that could possibly damage the unit. Install a new body gasket. Be sure that the holes line up. As you can see here, we had to enlarge some of the holes so that this one would fit. If you have to do this, be sure there is enough gasket material on both the inside and outside edge to provide a good seal. Now install the top cover and tighten down the bolts. You'll have to hold back up to be sure that the bolts are fully tight. They should be torqued to 150 foot-pounds. Before you can install the roller bearing on the shaft, you'll probably have to heat it. Use a torch and heat the bearing and then drop it in place on the shaft. You'll have to use a pair of gloves because it's going to be hot. Once it's in place, tap it down. To properly preload the bearing, drop the bearing retainer spacer in place. Set the split ring in the groove, making sure the split ring sits flush on the upper part of the groove. Measure the space or gap between the bearing retainer spacer and the bottom of the split ring with a feeler gauge. Remove the split ring and bearing retainer and add shims until the split ring just fits and there is no slop. Once the bearing retainer is in place, tap the split ring into place. The split ring is usually one piece. We've cut this one into two pieces. It will still do the job, but it's much easier to work with. Now install the retainer seal and bolt it into position. It should be noted that if while assembling the unit you should have any trouble installing bolts, you should retap any holes and use new bolts. Now install a new bearing in the upper body half. Use a cover plate to tap it down in place so as not to damage the bearing, and install the snap ring to hold it in place. Using a new motor gasket, install the motor. Put a little grease on the drive key to hold it in place and be careful not to knock it into the shaft. Next, install the bulkhead fittings and tighten them. Install the clutch hoses,